FYI, that's a thing. But anyway, like I said, I sent this code chunk right here in your email. You should have it copied and pasted under 5.1 below where we filtered, and run your script up through this point. So now if we look at our Father Ed recode, it's not wanting to work for some reason.
I ran into an issue like that yesterday, and for me the solution was waiting a little bit. Like I literally gave it a couple minutes and it worked again. I'm not sure if that's...
I'm just trying to restart our...
What were you working on at that time?
Doing this, I was just trying to go ahead, yeah, and for some reason it was giving me that like integer 0 response for it. Or extend 0. I don't know what that means.
I wonder if it's because table is stats, maybe? Well, nonetheless, that's not wanting to act right for some reason. But when you look at it, you should see that you have less than high school, et cetera, et cetera. So we've coded up to that point. So the one piece that I left out of this, because we talked about the recoding stuff yesterday, so in this little bit of instruction, the one thing we haven't done yet is where it says to go ahead and get those characters out of our friend's one variable, and just for in that one case, we're just going to store it directly over the variable, because that's what it's supposed to be anyway, but we got to get rid of that 98 or more. So there's a couple ways that you could go about that. One of them is to use regular expression, which is just ways of capturing patterns in any sorts of strings. It's incredibly powerful, albeit kind of a pain to use sometimes until you're learning it. But in the tidyverse, there's the package stringer, and it has several functions: string detect, string count, string extract, all sorts of different things. So if, for instance, you're just trying to detect whether or not there is some pattern of characters in something, you would use detect, and it will just tell you true or false or whatever. If you're trying to extract a specific set of characters, then you'll use this string extract, which is what we're going to do. And what we want to do is we want to extract from this friends1. We want to take this and extract just the numbers. So we tell it string extract df friends1, and then we need to tell it what pattern we want to extract. And in this case, we want it to extract all the numbers. There's a shorthand in and whatever pattern you're wanting to do, you put in quotation marks. And in this case, we're wanting to extract the numbers, and there's a shorthand for that, which is just 2 brackets, a colon, the word digits, a colon, and 2 brackets. And so this tells it any number 0 through 9. But this, if we ran this as is, we'd still have a problem in that we only told it one single digit. And so anything that's 10 or above, it's only going to extract that first digit. So if we add a plus sign after the digit, that is the character that tells our any number of the preceding pattern. There are other things as far as using the squiggly brackets, and you could put like 3, and that specifies we are looking for a pattern of exactly 3 digits. Or there are other things for saying at least this many things, or no more than this many things. There are operators that tell it look at the beginning of the character string, or look at the end of the character string, or starting with the 3rd character, look for this pattern. All these sorts of things. Any sort of character pattern you can possibly imagine, there's a way to do it in regular expression. But in this case, if we just run it with digit and plus, it will pull out all the digits, and you can see where it no longer says 98 or more. It just says 98. But you notice that all of these are in quotation marks because Stringer deals with characters. And so this is all now characters instead of numbers. But if we just wrap that in as numeric, now when we run it, it gives us the numeric version, and so we can just store that directly over our df friends1. And now when we look at the structure of df friends1, we can see that it is numeric now, and it's no longer that character because it no longer says 98 or more. What's up?
Is there any way you could make the font larger?
Oh yeah, sorry.
Oh, much better. Okay, so can we pause for a moment so that I can catch up, because again, I'm sort of learning. So the first thing that I tried to do is paste in your stuff, and I got an error, and that's when I reminded myself that I have to load the libraries and the data frame every time I open R, right? Fair. Okay, so now I'm caught up on that.
Is there anybody else who is not where we are? Okay, we'll get there.
Okay, then, so that was my first error, was just like realizing that there were no data. Then you provided us with information about, and I don't think I didn't write it correctly, but you provided us information for how to basically chop off text and just extract numbers if we're recoding a variable.
Yes.
Okay.
And that's this line right here, where we're just using string extract to extract the digits. Alternatively, like you could tell it to not extract, or more, or like just to exclude that and run the same thing, and it would work kind of the same way.
And so the way that you've chosen to do it would write over the original friends one.
Yes.
Even though we.
Yeah, but this is like one special instance in which like I'm cool with saving over it.
Okay. So this would not be something I would personally do with my data. But this is individual differences, and it's totally fine. We're going to do it Austin's way here. But Austin talked in the initial time about how you never ever want to fuck with your original data, just in case. So say you ran this and you accidentally realized that you only selected the first digit because you forgot the plus sign. Now, in theory, you might not be able to go back to your original data without, say, downloading it from Qualtrics or from something like that. So because I've made that mistake many times, I usually save my variables in a new way, especially if I'm learning programming for the first time, just in case, so that I can always have a do-over. Now, Austin's really comfortable with this. He knows exactly what we need to do, and it's fine to do it this way. My practice would always be, let's call it friends1 dot num or something, or end using his convention, so that way I know it's the same variable with just the numeric values. And if we were to do that, for example, then we would be assigning it to $friends1 dot n.
Correct.
Okay.
And that'll create that new variable. And she's right that normally I categorically say don't save over variables. Certainly don't start if we were running this, the way the way that I operate is leaving off your assignment operator at the beginning. Figure out from right here down, run it, make sure it works, take a glimpse at things to make sure things are what you want, pipe it into a table or into levels, whatever thing you're trying to check to make sure that your code worked the way you want, and then go back and add your assignment operator. That's always a smart move to make, unless you are awfully confident in your code, which even at this point I am not, and I won't say never, because if it's something that's real basic, yeah, sure, I'll go ahead and automatically do it. But typically, especially when it's several things, you don't want to store over that thing until you make sure that the output is what you are expecting it to be. For those of you who raised your hand and said you weren't where we are yet, have we figured it out? Or?
I have a question. So whenever we change the English 1 variable to get rid of not well and not at all, are those supposed to disappear from the data frame?
Yeah, they should. The ones that are not well or not at all, we are filtering them out from the data completely, and that will continue for the rest of this, because there's only 23 people, so we can't do any sort of analysis with that size of a group. So they are being completely removed from the data, which just means that you have to be mindful of that. And as we go through the semester, you know that like this is among proficient English speaker second generation immigrants instead of just broadly. Like that's just one small caveat that we add on to it. But we just don't have the data to be able to look at non-proficient English speakers. So for the sake of simplicity, just take them out of the data set altogether.
Yeah, that makes sense to me. I'm having a hard time. Mine's not filtering it out of my data frame.
Are you reassigning it?
Yeah. Well, it's also in the pasted code, right?
Well, the part of filtering them out is up here. You should have 2,353 observations.
I do, and then when I look at my data frame, in English 1, it's a factor with 4 levels.
Right, but run a table on it and see if those other 2 levels should have 0 observations in those levels. It's just like drop levels that we had to use on that Father Ed yesterday. Those levels still exist in the data, even though no participants have that particular value.
Gotcha. Thank you.
I had a question about like the percent in percent. So is that like a specific type of pipe?
No, this is just, I don't know what the technical name is for this particular operator. This is the equivalent to saying like greater than or less than. It's a logical test, and that just means that like if it exists in this vector of stuff. So it'll look, whatever you put in here, it'll just give you a true or false for everything in whatever you're putting into it. That like, do any of these values exist? And if so, it'll say true, and if not, it'll be false. It's a really, really handy operator to have. One of the unfortunate things is that the inverse of this operator doesn't exist naturally, that there's not like a not in something. That function does exist, but it's through another library that if you load that library, like you can specifically call %nin, meaning not in this list of stuff. But like this is a very handy logical operator to have in your tool belt.
In regards to Anna's comments earlier, would you advise to save an original raw data set and then create a copy of it to use in?
Well, you shouldn't need to create a copy of it necessarily. The goal is like, yes, you do have your original raw data set, and then everything in your script stems from that raw data set. Where you run into problems is where you create separate subsetted data sets, and then you end up, say you're collaborating with somebody and you need to send them the data file, but you grabbed the wrong one. And so like the way that I operate is in my studies folder. I have a bunch of different folders that are each of the studies that I'm running, and inside that I have a structure where there's always like the absolute raw file. It is when I export from Qualtrics, this is the file that it is, and it is the absolute raw. And then I have a script that's usually called like raw to analysis, and that script, when I run it, it does all the processing of the script to create the data frame that's actually used in the analysis and save that script. And then I will then take that data frame specifically and store it as like the analysis data frame, and then have a separate script that's for all the analysis. And but as far as like within a script, like saving extra subsetted data frames, you can do that, but chances are in the long run you're going to end up running into problems somewhere along the line when, like I said, you end up having to go back, you add more data, you need to take out data, whatever the case, and when you run your scripts, like if you didn't run that other one, then this second data frame that you saved isn't going to be updated and it's going to give you bad information. So the goal, and that's one of the nice things about these pipes, is instead of having to constantly be creating new subset data frames, you can just take the master data frame, if you will, and subset it as you go.
There are individual differences in how you manage your data, but it is a good idea to start to think about data management. My strategy is a little bit more tedious than Austin's. I obviously save the original data, And then the first time I open it and I'm gonna do things like calculate total scores or run some pretty basic things, but anytime I'm gonna do anything with it, I usually save it again with the date so that I remember like that, okay, these are the data that I fucked around with on February 2nd of 2017, you know, and then, and I like to keep my scripts with the same date so that I can also remember what I did that day to get that. But Austin's way is a much cleaner way in terms of like, you know, once you have your clean data, which is what we're gonna do here, right? Once we have our clean data with all our variables created, with our dropped cases, with like, these are gonna be the people we're gonna work with the rest of the semester, one data set, and then whenever you're gonna do something new with it, do it all within that script is a good idea. But whatever you do, there are different ways of doing it. You just have to kind of figure it out. It's not a good idea to not have a strategy. Just like you have to have a strategy for filing your stuff, period. Right? How are you going to organize your class notes? How are you going to organize your like day, your book? You know, how do you know where you're supposed to be or what assignments to do? You need to have a strategy for organizing your data.
Absolutely, and one thing I also wanted to point out about like this working with stringer and just character strings is this in conjunction with systematically naming your variables can make a world of difference. For instance, like you have, you know, it's normal for us to have, say, 5 different scales on like whatever survey, and so we have like SDO1 through SDO12, and then LMA1 through LMA15 or whatever. Using this, you can do a lot of things as far as telling R, like, hey, go across my columns, extract the column names, look for the repeating patterns, and then, you know, take the mean across each of these things. And so instead of having to manually go in and type in all these column names, you can use those column names. So like when my convention is that my variables that need to be reverse scored are labeled, you know, whatever .r. And that's my reminder to myself that like, oh, hey, this is a reverse scored item, so when I pull it in, I need to reverse score it. And it makes it really easy just to say like, hey, detect the string .r in all of the data frame, and because all of my scales are 1 to 7, then I know like if it has .r in the name, then subtract it from 8, and now I have a reverse scored item. And I don't even have to worry about scrolling through and being like, let's see, where are all my reverse scored, you know, things. And so one of the keys to really anything dealing with coding and data is being able to think programmatically and systematically about it. And the more that you can consistently do, when you have patterns, you can tell R, like, hey, here's this pattern and I need to do this thing with it.
And I want to say one more thing and then we can maybe move on from this. These are great questions. We have in whether it's SPSS or in R, if you have a measure that you typically reuse a lot in your lab, especially if it's a measure that's a bitch to score, like the sexual experiences survey, which you guys know is horrendous. You can create an R script that is only for scoring a measure. And then no matter which study you're using, no matter which data you're using, you could just read in your data from this particular study, run that script to get all your scores, you know, your total scores or composite scores, and just save a project or an R script that is like scoring SES or scoring whatever. And then that way you don't have to reinvent the wheel every time and you have it available to you. As long as you've named your variables, well, actually you can change that too, but for me, the easiest thing is always naming my variables the same, like SES01, SES02, and then when I run the script, no matter which data it's from, no matter which study, I know that I'm going to get the same scores. So there are other ways to organize your data that are not just by project, but also by like, you know, kind of what you need it to do.
Also, could you walk us through the as numeric extract one again? I just want to type out what you said.
Yeah, so if we run just like this inner portion and ignore the as numeric, so when I run this, it's just going to run that string extract. And you see that this actually prints out the numbers, but they're in quotation marks because it's actually, they're characters. So that's not the number 10, that's the character string 1 and 0. So then just by taking that and putting as numeric around that, it will do this same thing, but then make each of those numeric so that now when I run that line, it now actually gives me the numeric versions of those. Because if I took off the as numeric and stored it and then look at the structure, it'll tell me like friends 1, character. So when you wrap that in as numeric, it now makes friends 1 into numeric. Does that make sense?
So was it a factor or character vector?
Before it was a character, I believe.
Why do you have to do string extract? Like, why can't you just do as numeric to that particular?
We are now getting ready to make numeric versions of our factors. That's this next bit, so let's actually move along and it'll answer your question. So now what we're wanting to do is make numeric versions of all of our factors. So here all I'm using is select if is factor and then lapply levels. So running this df select if is factor, all that does is it selects all of the variables in the data sets that's a factor, and then it's going to pipe them right into lapply, which, as a reminder, that applies some function across a list. And in this case, the function that we're going to apply is levels, so that we can go and we can look at all of our different factors and see what the different levels are. Because you can wrap a factor in as numeric, and it will output some numeric version of things. For instance, here when we look at the levels of sex, if we wrap sex in as numeric, it will assign male to 1, female to 2. Here, United States will be 1, Central South America will be 2. Skipping down to education 3, some high school will be 1, graduated from high school will be 2, on and on and on to where, JD, MD, PhD, etc. will be 9, and then other will be 10. So I would hope that everyone could understand why, we might not want other to be coded as 10 when all these others is this linear pattern of increasingly more education, but if other is coded as 10, then that's to say that other has even more education than those who got their JD, MD, blah, blah, blah. So you have to be careful when you just wrap factors in as numeric, because you have to be mindful of what those levels are. So on these up here, since these happen to already be in the correct order, when you wrap mother's ed in as numeric, it'll correctly assign 1, 2, 3, 4, 5, 6. But that's because the factors, when we loaded them in from the SPSS file, they were already leveled and ordered factors. If it was just character, it'll go in alphabetical order. So if we change mother ed to a character from a factor and then run as numeric on it, or rather run it back to a factor, it will automatically do it in alphabetical order is the order of the levels. So that's why whenever you're doing these things, you have to be mindful of checking your levels and not assuming that your levels are in the correct order. In this case, all of ours are, except for that education 3, and that's just because we need to do something with this. Now, as far as what to do with that, so I'm going to go ahead and paste in a little bit of code here leading up to that education 3. And so what this is doing now is we are just creating sex.in, and it's just wrapping sex in as numeric. And it will give us that 1 and 2, because here's our levels. So for every time male is in the data set, it's going to give us a 1. Every time female, it's going to give us a 2. For father ed, it's going to be the same thing. It's going to give us 1, 2, 3, 4, 5, 6, etc. But now, like I said, for education, it's going to assign other to 10, and we don't want that. So here, there's a couple different ways to do it. I'm showing you the shorter way, but the less explicit way for now, where this is going to do that, and it's going to give us 1 through 10, with other being 10. And so then all we really want to do is separate, and this is what I'm talking about right up here, where I want that other to be set as -999, so it's something that stands out. Because we don't want to filter out these other education people necessarily. If we're working specifically with that variable, we might need to leave them out because they don't really fit in anywhere else. But, if we're not looking at that variable, then that's how many people that we don't want to exclude. So instead, like now, one of the really great things about the tidyverse is the way that when you have these mutates and when you're creating tibbles, it will kind of work within itself. And what I mean by that is, like with this line right here, we create education3.n. And then on the next line, we can do something with education3.n. So for instance, for example,
hang on 1 second. Just so you know, this is like, maybe it's just me, but I am struggling to listen and type at the same time.
Okay.
So I'm trying to type all the code you just put in, and I really want to listen, but I can't do them both at the same time. Can you give me a second to
Yes.
type? Thank you.
While I'm working on this, what I want to demonstrate is like what I mean by one of the nice things about tidyverse and being able to use variables in line.
Okay, I have a couple of questions. First of all, is there a closed parentheses missing from the?
Yeah, because there's another line that I'm adding on.
Oh, okay, okay.
I just want to demonstrate this first. That's why I actually hashed that out, so it wouldn't try to run.
Okay, and so the recode variables were the ones that we had done already?
Yeah, because up here is where we created, in that thing that I sent,
Okay.
that's where we created the recode variables.
Okay, perfect. So we had the original father ed, then we recoded the father ed, but it's still a factor, meaning it's just words.
Right,
And now we're gonna change those into numbers for analyses.
correct.
Thank you.
All right, so right here, I'm creating a data frame, and I'm just telling it x is 1 through 3, and then I want y to be whatever x plus 3 is. And if I try to run this line right here, it's not going to work. And so because if I wanted to do this, instead I would have to make a data frame that x is 1 through 3, store that as an object, and then say like, all right, now make y x plus 3. But with Tibble, which is the tidyverse data frame, it's just called Tibbles instead of data frames, when we run this chunk of code, it will assign x 1 through 3, and then when it gets down to the next line and it says y, it will add 3 to whatever x is. So that's what I mean about being able to do things all at once and not having to like store it and then run a second thing to operate on what you just created. So we can leverage that to our advantage here. We create Education3N as the numeric version of Education3, but we have those others that we don't want to be coded as 10, but we know that it's going to because we smartly checked our levels and saw that like, oh wait, other is going to be coded as 10 and we don't want that. So now we just add on an extra line here where we'll say Education3N equals, and we'll throw in an if-else statement, which I'll discuss in just a second. We're going to say if-else Education3N equals 10, which is that other thing, then output -999, else just output whatever Education3N is, and then close that extra parentheses. And so whenever you're working with these if-else statements, you give it some logical test, the output if the test is true, and the output if the test is false. So what we're saying is, if Education3N equals 10, then output -999. If not, then just output whatever that variable is. If it's not 10, then just output 1 through 9, whatever it happens to be, and save that as the Education3N variable. So in other words, all it's doing here, we're creating a numeric version, but other is coded as 10. And then here, we're just changing it to say, hey, if it's 10, then just make it negative 999 instead. And so whenever we run this chunk of code, it runs, come back and store it into itself. And now we have created the additional variables of all of our n's.
So to be clear, in this case, you actually did 2 steps for Education 3 all in one code. Well, first thing, you took Education 3 that was factor and made it numeric by using education3.n equals as numeric.
Mm-hmm.
And then you took that new numeric variable and you said, basically, if Education 3 is equal to 10, then make it negative 999.
Otherwise, leave it what it is.
Just copy it and put it as it was.
Yes.
Okay. But you did have to do those in 2 separate steps because you needed it to be numeric first.
Yes. Now, the alternative, and I discussed this a little bit in the video that I'll just briefly cover because case when is a wonderful function to know. There's a function called case when. And case when is used for if you have multiple if-else statements. If you're only like trying to pick between 2 outcomes, like cool, and if-else covers you. If there's 3 things, and say you want to say, if it's red, do this, if it's blue, do this, if it's green, do this, you could nest 2 if-else statements. Like you could just continually do like 17 if-else statements to break apart all these different things. But it very quickly becomes problematic. And if you wanted to do that, it would be like...
Wait, hang on, I'm sorry, I ran into an error running the code. I don't know if you guys did too, but birth region.
So it has some weird capitalization.
Yeah.
I can't figure out, like the B and the R and what's in parentheses.
Yeah, I didn't see it as like, okay, so let me see if that's what it was.
Is it this as numeric stuff that you're...
Birth region dot n as numeric birth region. I couldn't. I mean, I did do this, but then when I ran it, it basically said birth region. I don't know why it doesn't use it. Maybe I did that.
Oh, there we go.
I added .recode to the end of birth region because 3.recode was at the end of birth, and that was my fault.
So let's just say that we have like x that we want to do some if-else, and so if-else x equals 1, we want something. But if we're doing multiples, then we'd say like if x equals 2, we want whatever. And then if else, and then if else x equals 3, something, and it works its way down to where like finally the one at the bottom will be like if else, whatever else, and then there's like 17 parentheses that you have to keep track of because you have to close each one of these nested if else statements as you work your way down. So if you're ever dealing with more than like 3 things, using if else can be a pain, but enter case when. Case when is a nested if else statement. So the way that you write this out would be, well, this part is just because I had it in the mutate. But so you say case when, and this is basically if education 3 equals some high school blah blah blah, exactly whatever it is, then you use the tilde to say like set the value to 1. If it's this, set it to this. If it's this, and you can work your way down. So if ever you're in doubt, you can manually, and FYI, this wouldn't run as it is because like I said, this was in a mutate. So right now I haven't, like it'll say there's no education 3 because I'm not calling a data frame. So I'm just putting this up here for your example. I talk about it in the overview video. But I just wanted to point out that if you have multiple if-else statements, case when is going to be your friend. And you can do this across, it doesn't just have to be, education 3. If you have other things, other if-else statements for other variables, you can do that. And then one other thing that I point out in the video is that if this will read in, like, down the row. It'll read things in the order that you do them and assign those values. If your final thing just says all capitalized true tilde whatever, we'll say, you know, -999. That using true at the end is the catch-all, which means that if there's anything that didn't receive some value because, like, you forgot, let's say we forgot to put on this line right here, and then we said, you know, true equals 75, or rather true tilde 75, then everyone who had that that PhD level thing would get coded as 75 because we didn't give it any explicit value. So that's a good way of, at the end, if you throw on, and that should only be one, if you throw on true equals, you know, or excuse me, 75, when you run this and look at the output, if you have anything that was coded as 75, you can go, ah, wait, I missed something somewhere. I forgot some group to specify what it was. But this is just, this and these two lines right here are doing the exact same thing. It's just that this way is manual, and it'll be nice to know case when, because like I was saying earlier, that if it hasn't already been defined as a specifically ordered factor, and when you just import it from SPSS and it reads it, or when you import it from Qualtrics and it reads it as a character column instead of as a factor, you know, it's going to be alphabetical order automatically. So if you just try to wrap it in as numeric, it's going to be all out of order. So this gives you a nice, simple, straightforward way of being able to explicitly, and then you know that they are ordered, that the numeric version is ordered in the proper order, if that makes sense. Does anybody have any questions before we move on to the next thing?
I have a question about a comment. It might be helpful if people know about the question mark before certain functions so that you can
Oh, yes.
help yourself.
So if in doubt, and you're trying to figure out how to use a function, you can throw a question mark in front of it, and when you run it, it'll pull over your help file over here. And this case when isn't a very good example. I mean, it does give examples down at the bottom. Let's say we want help on, I don't know if that would be a good, let's just look at linear models. Because when you look over here in your help, it'll tell you like all the different arguments that can go into it. So you have a formula, a data, subset, weights, NA action, all these different things. Whatever shows up in this help file is the defaults. So for instance, if you're trying to make a linear model and whatever the singular.ok, you know, argument is, it's going to be true. If you want to change it, you have to explicitly put in there, hey, false, like for this particular argument. But anything that you don't specifically specify is going to default to all of these. So the method is going to be QR, model is going to be true, X is false, Y is false, et cetera, et cetera. But so when you're looking in these, it will tell you all the different arguments that it takes and then what each one of it does. If you run one question mark and it won't run, try two question marks, because the one question mark runs for functions that are loaded. But if I'm trying to look up the help file for some function that's in a library that I haven't loaded already, it's not going to be able to find it unless I put two question marks in it, and then it will be able to find it.
So just like a comment, I use the question mark often to find what package something comes from so I can search it easier on Google. So like if something is from Dippler or dplyr from case when, I'll write case when dplyr so that it searches easier, because sometimes the help is confusing.
No.
Knowing which package makes it easier to search online.
All right, anything
I have a
else?
question. On this case when, you may have said this, but what does the true argument do?
That true argument says anything else. If there is anything that's not caught by one of the preceding statements. So if we had some other level of education that said like clown school, and we didn't say code clown school is 3, or whatever, and it'll say like, all right, well, we found each one of these things and gave them this value, but there's like this one thing that wasn't assigned a value, it's getting assigned 75. So it's just going to catch anything, because if you don't have this, if you don't put true here, and clown school is an option that you didn't specify, it's going to change it to NA, because it's going to be like, hey, I wasn't told what to make this value, so I just make it NA. But by putting true tilde 75, anything that doesn't explicitly have a value specified up here gets coded as whatever you say is the true.
Could I say that it's assigning 75 to NAs?
It won't do it to NAs, because NAs are, like, they're not a value. The clown school is a value of clown school, but it just wasn't assigned something. NA is not a value, like it's NA. It's just like when we do means, and if you don't remove NAs when you run mean, it's going to, the output is going to be NA, because NAs can't do anything. NAs are always NAs unless you specifically assign something to those NAs. But the things that aren't clown school would be made into NA if you didn't give it a value without this true statement at the end.
So what is the benefit of doing that? Is that just to see if you missed something when you ran
Yeah.
it? Okay.
Yep. That's I typically will throw that at the end and make it something obscure, and then pipe that into table.
So for example, let's say that we were only interested in I don't know, people who were college or above educated, and everybody else we wanted to consider missing value. Instead of typing in, the less than high school equals -999, less than blah, 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 we could just not specify those and at the end put true as -999 if we explicitly wanted to make them a called missing value. See, it's hard to type and listen at the same time.
Yeah, sorry.
That's okay. I was just wondering if you could save yourself code if you knew for sure that what you wanted was certain things to be missing values.
Yeah.
So say we were running gender and we ended up with very few people who were transgender.
Then you would just put transgender.
Or if you had enough categories, some people are now using 11 or 13 different categories for gender. If you had enough of those, you could just not specify those categories and at the end put true tilde -999.
Yeah.
Okay.
Exactly. Yeah, because if you want them to be NAs explicitly, then you need to not have it. One of the things with K-SWIN, at least as far as I know, you can't have different assign numeric and character things. So if you try to code the others as 1 through 9 and then instead make the other just save it as other, it's going to throw an error and it's not going to let you. The output has to all be homogeneous as far as the type. I think NA actually does work. So if you wanted to explicitly make it NA and we threw on other and instead of -999, if we wanted to make those NA, I believe, I'm not 100% sure. Well, I guess we could find out. Yeah, so NA won't work, but when you put in -999, then that will work. But yeah, but if we wanted to make everything characters, and if we just made this A, B, C, D, E, F, G, H, I, J, that'll work, and it'll output those characters for us. But whatever you're outputting has to be all one type. All right, so before we go on, for the sake of simplicity, we're going to filter out those people who have those -999 values in the education thing. So go ahead and use your filter to remove and store back over the data frame those -999s, and once you run that, you should have 2,314 participants in your data set. So again, here we're going to be using that filter. So if we start from our data frame, and we're going to filter, and we're going to say if education 3N does not equal negative 999. Because remember, whatever passes your filter is what gets retained. And the exclamation point is the negate operator. So exclamation point equals means does not equal whatever. And so we run that just to make sure, like, cool, yep, it's running correctly. So then come back up and store it over our data frame. And now we have 2,314 observations in our data.
Did you have brackets there before?
Brackets?
For the does not equal? Oh wait.
I think the exclamation point has to touch the equal sign.
Yeah.
That one, right? Opposed to ace.
Yeah, the exclamation point equals is one thing. Don't separate those.
Somehow I didn't have an education 3N.
Well, I didn't either. I forgot to assign an operator.
Yeah, if you come back up here where we did these mutates,
So gotcha.
you gotta store it
You're
back over.
right.
I just did the same thing.
It takes a while to get used to remembering to do that for sure.
So that negative 999 was arbitrary.
Yeah, that was just because then, well, not necessarily, I mean, arbitrary in a sense, but not completely. For instance, as I was working on the MANOVA lab for the next one, these negative 999s are still in the data. And at first I was going through and doing my stuff, and then I was like, man, I'm getting some crazy Mahalanobis distances here. And then I realized that, oh, it's because I have a couple handfuls of people that have negative 999 on this value. But that's also the importance of checking your descriptives, which is next.
Also, it's pretty conventional to use negative 999 for missing data. A lot of public available data sets will use negative 99 and negative 999.
Because it makes it pretty obvious that, like, wait a second, something's going on here. This doesn't seem like a value that should be occurring in the data, and kind of helps flag things for you.
Yeah, sorry, I don't know how this works, but when I did the mutate, it did the recode for everything except for the job stat 3 and the education. So it didn't recode it.
Up here?
Mm-hmm.
Are you sure you got the capitalization and such right? Capital J, capital S on 3?
Yeah, I ran it. When I opened my table, it didn't.
Did you store it back over?
No, I didn't. You did the same thing I did. Or didn't do the same thing I did.
Okay, thank you.
All right, so now that does everybody have 2,314 observations in the data set?
Yes.
All right, so going back to our homework, that gets us through number 5. So number 6, like, we want to look at our descriptive statistics: mean, standard deviation, min, max, skewness, and kurtosis. So here is.
Somehow I'm also not at that spot where I have 2314. I also did this on the damn operator. Sorry. No.
All right, so here on number 6, we're going to be using.
I have 2,337. I have no idea.
337.
Check your. I ran into the same issue, and it was because my filter call wasn't filtering out the negative 999s. Like if that filter didn't work, then you'd have 2,337.
Yeah. Once you ran this filter, did you store it back? Did you assign it back to the DF?
Yeah. Shit. It's got a little operator
Mhm.
thing
I also feel like I didn't. Well, I still have 72 variables, so somewhere we had filtered certain variables that I didn't run that, and I think it was at the beginning.
Oh, that was the very first
lab.
thing, yeah.
Oh.
All right, let me know if we need help back there. As far as the descriptives go, my default, just for broadly speaking, glancing at descriptives, is to use the describe function in the PSYC library. And so for here, you could, pipe your DF into, select, and sit here and go through and type in all your different variables, but basically we're wanting the descriptives of all of the numeric variables. So instead of selecting each variable one by one, we can use select if, and we'll say is numeric, and then pipe that straight through. So if we run just this portion, it's going to automatically select all of our numeric columns. And so then we'll just pipe that right into describe. And so now looking across all of our numeric variables, we can see, the mean, standard deviation, median, blah, 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 all this sort of stuff. We'll talk about what we're looking at here in just a second once I think it's resettled. But one thing I wanted to point out as far as we have our homework assignment that you need to fill in all these values. And we have described outputs all of these things, but all you need for the homework is the mean, standard deviation, min, max, skewness, and kurtosis. So if you're wanting to make it easier for yourself to just copy and paste those things, you can take this output, add another pipe, and pipe it into select, just to select those specific columns that you're wanting. So I want to select the mean, SD, min, max, skew, and kurtosis. And now when I run it, it's just going to output those for me. You could take that a step further. Sorry. Right here is what we're running. You could take that a step further, add on another pipe, and then write _CSV, give it a file name, and it will output this table into your working directory as a CSV that you could just copy and paste in bulk. Now here we do have additional, columns or rows because we have all our numeric things. But you could actually, filter down beyond that to say, if you wanted to say only select Friends 1, SMA, SRA, in this order, and literally have a straight copy and paste into your document. But that's as far as I'm getting today so that we can move along. But so when you're looking at these values, you're try to get as much of this on the screen as possible. When you're running your descriptives, you should be thinking about whether or not values that you see make sense or not. So if you have something that's supposed to be a 1 to 7 scale, but you see the value 77 in there, chances are your undergrad RA accidentally hit 7 twice. So you're looking at your mins and maxes to make sure, does this make sense? In this case, our friends are between 0 and 98. 98 seems like an awfully big number of close friends. But also when you're looking here, with those skew and kurtosis, for the skewness, we're looking for less than 2. Once it gets above 2, it might be problematically skewed. For kurtosis, as a reminder, we're looking for values less than 4. Once you get above 4 on your kurtosis, now you may have some problems that need to be adjusting. So friends is skewed. You can also look at your mean versus your standard deviation. If our mean is 11 and our standard deviation is 16, then that's going to imply also that you have that skewness. But we have a skewness statistic, so we don't really need to think about it.
I want to pause for just another second. So up until now, everything we've been doing is trying to kind of prepare the data that we're actually going to be using to look at our assumptions and to run analyses for the rest of the semester. So we've spent time filtering data, we've spent time making sure that if there are cases that are too few, like with our English, non-English speakers, then we take them out. We've done all this stuff just to get to the point of now being able to look at some of the basic assumptions. And the very first one we're looking at are some assumptions of univariate normality. And so that's the transition here, is like getting to this point to describe your data is all about getting to the point of being able to say, like, do my variables, well, A, do they make sense? Do we have coding issues? But more importantly, at this point, assuming that that part had checked out, do we have the reason to suspect that we're going to be violating normality at the univariate? So that's the kind of the transition we have made.
Yes. And we'll actually come back to talking specifically about these once we get through our next step of graphing these things. One thing I wanted to show you here that I just kind of threw in right here just because I don't know where else it really fit in nicely, but as far as like whenever I'm looking at a new data set, there's this really nice function from the final fit package called missing plot. And when you pipe that in, it's really hard to see on this. But basically, it allows you to look across your variables, and wherever you see like these light lines, that's a missing value, and the dark ones are not. So you can look and you can see like, okay, well, we're missing quite a bit of the job score 3 and income 3, missing a bunch of these, missing some of these. The rest aren't too bad, but one of the nice things about this is it can allow you to see if you are systematically missing things. If you're missing literally half of the values on something, then maybe the logic in your survey didn't work properly, and like one of your conditions like didn't get directed to this particular block of questions or whatever. So this function I just threw in there because it's a and is double, is numeric, same thing.
It works both ways.
Is the light color the missing?
Yes.
So can you also show us how we can zoom so we can get a really pretty picture on the values map?
Well, you can
Zoom.
up here in your view, you can say switch to plots, or sorry, which one is it?
Even just clicking on the zoom in there.
Oh.
At least for mine, it made it a lot bigger. And
Yeah, and I actually use keyboard shortcuts. There's a lot of them that are real nice that, like, I think mine's Command-Shift-6. If we're looking at that, and, okay, I haven't set up my keyboard shortcuts on this account that is separate from, like, my actual account, which drives me crazy because, like, my pipe shortcuts aren't working, and I need to go through and finish setting it all up. But yes, keyboard shortcuts to quickly full screen your plots and that sort of stuff can be really nice too.
So first issue I had was an error of not having that package, the final fit package. And then, so I tried to install that package, and then I tried to rerun it, and then it's telling me error in load namespace, saying that I have too old of a version of tidier package loaded.
yeah, but when we opened R, the first thing we had to do was call in the library.
That I'll get with you after that, because it sounds like there's a problem with updates, but you have to be careful because, like, if you update tidyverse to the current most recent version, it'll cause problems with some other things that haven't caught, because there was actually just recently an update. And just Monday night, I had to frantically go back and backdate because I had accidentally updated dplyr. We'll talk about that because this is not important to what we're doing today. Like, I just wanted to throw this in there so that y'all have, like, oh wait, there is some function out there that will just give us a quick glance of what's missing and not, but it's not important to the lesson. I'll work with you on that, getting your stuff updated or correct. What I do want to do, we're going to skip down to number 9. Where we're going to graph, like we just want to produce graphs of our univariate distributions with a superimposed normal curve on it. So for this one, we're going to use a function that's in the MVN library. And I'm going to just use the double colon to call it instead of loading the library. And then the function is lowercase mvn. So it should be capital MVN, colon, colon, lowercase mvn. This is the multivariate normality package. What's nice about this is, let's start by taking our data frame, and we're going to select, I guess there's really not a faster way to do it. We'll select the variables that we're wanting. I'll go ahead and put that up here. If this was a cleaned up data set where I already had, I could just call is double, but like I have extra double columns because of we still have like the recoded versions and blah blah blah, which is why I'm just manually typing these out. Once you get that select part put in, go ahead and highlight and run like those couple lines just to make sure. That's how you can, if it runs, then you know that you don't have an error. If you try to run that chunk right there and it doesn't, then you know that you have some sort of typo or whatever in here that you need to fix. Alright, and so then we're piping that subset data set into this MVN function. And we're going to tell it for our univariate plot we want histograms. And then you also have to include some sort of univariate test. If you don't, then it won't work. It doesn't really matter which one, but we'll say capital SW, which is the Shapiro-Wilks test. I added this caveat in here because this will output some like p-values and stuff for testing the normality, but it's going to tell you that nothing in here is normal, and that's literally just a function of when you have massive data sets, like it's not going to be normal. Because if you think about it, if your standard error is your standard deviation divided by your sample size, and if you have 5,000 people in your data, that's going to be a really tiny standard error. And anything at all that deviates is like, no, this is, way outside the standard error. So keep that in mind when you see it say like, no, these are not normal. And instead, just look at the plots. If you get this error here that says figure margins too large, that means that your plot pane is not big enough. So just open that up, make it a little bit bigger. And maybe because I'm zoomed in too much.
I got an error about error in call means x na.rn equals true, x must be numeric. So somewhere I must have been calling in.
Yeah, one of the variables that you pulled in.
It's probably friends one.
A character? Well, that's the one that we changed to, we extracted the numerics and then made it into -999, or sorry, no, friends one. Oh wait, yeah. So that that was up here, I think. No, that was the one that we did. We changed because we got rid of that 98 or more.
I have a question that I think could be beneficial. the group.
Mm-hmm.
So something with the packages that I have loaded or not loaded has given me errors loading these MBN and the final fit packages.
Are you calling the double colon?
I'm writing it exactly, so it's doing it. I'm still having an issue loading it, and I'm guessing that's because I have a certain package installed or loaded. It's causing issues.
I wonder if you didn't update Tidyverse, and that if you have the most recent thing again. Well, I'll check it out once we're done here in just a few minutes, and look at what your current versions and things are.
That might be something people might run into.
Yeah, and for sure, it's just not something we have time today to talk about that particular thing that you have to figure out in R.
With the margins, I'm sorry, what did you do to fix them?
So when you have when it says the file margins are too large, you just literally need to make your plot window bigger, because if this is too small, it's saying I can't fit 17 plots in this tiny little window. And so like this one doesn't look very good just because it's because of my Zoom and whatever. But so here is just, I really wish that this was better, but these red lines are your normal curves. And so between looking at these,
You could press Zoom, I think, on there again, and make that full size. So we can get a little bit of a better sense of what it all looks like.
So between looking at this plot and those descriptive statistics that we ran before, like now you're looking across your univariate normality. So it's pretty clear that friends 1 is not normally distributed, which we saw with both our skew being greater than 2, our standard deviation being greater than our mean, and now looking at it visually, you can see that it's lopsided. It has that positive skew to it. Whereas some of these others are pretty well evenly distributed. Now, as far as not the plot, but what the console outputs when you run this function, this is what I was talking about, where we put in that univariate test equals SW, and so this is running the Shapiro-Wilk thing, and like I said, it's going to tell you that no, none of these things are normal. But when you look at the plots, you can go, that looks pretty normal to me. So just remember that when you're dealing with large sample sizes, p-values in this case are pointless to you, because like I said, it's just a mathematical function of your standard error is tiny when you have massive data sets, and so everything is going to be bigger than the standard error by a huge margin.
Okay, so I want to make a couple of comments here, given where we are in terms of a pause point. We're going to keep doing Lab 1. We're going to push back the due date for the homework assignment. I mean, it doesn't make sense to have you turn it in before we've had a chance to talk about how to run everything. But for class next time, please take a look at your descriptives that we ran, take a look at your graphs, and maybe email Austin and I individually, right? Or you can email both of us, but each of you individually email us with what variables do you think don't pass the normality visualization test, not the Shapiro-Wilks, because they are all non-normal from there. Meaning their standard deviations are larger than their means, their skewness and kurtosis values are outside of those 2 and 4 ranges that we talked about. And visual inspection of the graphs suggests some serious departures from normality. And then email us, based on the slides that were in the lecture, what kind of variables do you think we ought to transform, and what kind of transformations would you propose? Okay, so you'll have looked at the graphs to figure out which ones they most look like. And remember in lab I showed you, here are the 6 different ways that graphs can look and they're serious departures from normality. That's the one you want to show to everybody? Yeah, So when you visually inspect your graphs from your output, email us to tell us which variables you think are candidates for transformation and which transformations would you propose. That way, when we pick up in lab next time, where we will actually be doing transformations, we're all going to be kind of on the same page. Okay? Sound good?
Yep, so in other words, we should, looking at your actual homework assignment, you should be completely through number 11, and we're going to pick up right here with the next steps being like, all right, now we've decided what transformations we're going to do. We'll actually do those transformations, look at those descriptives, make a couple plots of those, and then we'll be on into imputing stuff.